Okay, so we're doing the chain rule and the product rule when we have big ugly functions like this, which might be functions you might use for your models. Now I do recommend making your models as simple as possible, but you should know how to do it if you do want to have a more complex function. So let's do this. We see here that there's two choice variables, there's s and j, so we're going to have two first order conditions, and our first order conditions, we'll take them one at a time. So the first one is the derivative of your payoff function with respect to s. And to start off, the first step really is to find all of your s's, because you know anything that's not an s is either a constant or it's some function that has a pathway to s. So let's underline all of our s's. There's one, there's another, there's another. The second step is going to be to figure out where you need to use the product rule. So chain rule, product rule. Product rule is a little bit more difficult, so you need to have your brain prepared for it. And you'll have to use the product rule anytime there's two s's or two choice variables in a single term, where a term is something separated by a plus or minus sign. So our first term only has one s, but our second term has two s's. So we need to watch out when we get to the second term that we're using the product rule. And then our third step is going to be to follow all of our s's back all the way to the beginning of their pathway. So we see here that s influences r, and r influences t, and t influences p. So that's the pathway that s will get all the way back to our objective. We care about p. So maybe p is happiness, or p is joy, or p is probability of winning a game, or something like that. So the chain rule says we'll just follow that thing back. So to do that, we've got a couple of constants sitting out here. That's not a problem. Those just behave like constants. We'll just pull them down. And then now we need to take the derivative of this whole thing with respect to s. So that's going to be the derivative of p, and we work our way in with respect to t. Derivative of p with respect to t, where we note that p is also a function of k and w. So we need to pull those down to remind ourselves that k and w also influence p. And then t, we'll take the derivative of t with respect to r. Derivative of t with respect to r, where we also note that t is a function of a couple of other variables, f and I. And then moving our way in, we take the derivative of r with respect to s. And r is not a function of anything else. And the nice thing about this notation is it kind of looks like these are canceling each other out, right? So this whole piece gives us derivative of p with respect to s. And just visually, that's kind of pleasing to us, since the notation looks like there's cancellations. That's the beauty of the chain rule. Alright, so we're done with our first term. Now we have to move on to our second term, and this is going to be kind of hairy because we use the product rule. And the product rule is derivative of, first times the derivative of the second plus second times the derivative of the first. It just kind of has to go over your head, over and over in your head until it sinks its way in. First times the derivative of the second plus second times the derivative of the first. So first of all, let's just identify the first and the second. What are the first and the second? Well, those are the two functions of s. And here it's a little bit tricky. This one's actually pretty easy. We can follow our s to the pathway. Back to the pathway, s influences q, and q influences t. So this is going to be one of our functions. That can either be first or second. It doesn't matter which one you define as first or second. This s is actually sitting by itself. So we can define this by itself as what we're going for, or we can define it as having this constant multiplied by in front of it. It works either way as long as you pull down the constant as you're going. So here's our two functions. Let's just arbitrarily label this one as the first and this one as the second, so we can keep things straight. So when I say first, and we have to notice there's a minus sign here, so we'll pull down the minus sign and maybe even add some brackets to make sure our minus sign carries through wherever it needs to be. So first just means we pick up the first and put it down exactly like it is. First function right here times the derivative of a second. So now let's take the derivative of this, and we just did something similar using the chain rule, so let's do this again, which is derivative of t with respect to q, where t is also a function of h, w, and j. And then moving our way in, derivative of q with respect to s. And q is not a function of anything else. So we've now completed first, exactly like it is, times derivative of the second. And now we need to do plus. And this is why it's very useful to have the brackets, because otherwise we'd have to distribute that, that minus sign, and it's very easy to forget to do that. So we got plus. Second, meaning we pick up the second and put it in there exactly like it is. Second, t, h, q, s, w, j, second, times derivative of the first. And this, of course, is just s times a constant, which is just going to be the constant. That's a little bit like, this is kind of like 3s. So the derivative of that is just 3, which is why we got our fj derivative. So we just finished second times derivative of the first. So we're done, except this is a first order condition, so we have to remember to set it equal to 0 like all first order conditions. Alright, and that's basically how you use the chain rule and product rule. If you still need some more help, I'm going to now erase this and go through the same exercise with the variable j, which is also a choice variable here. So, yeah, I'll do this in green. A little bit messy, but we're going to get there. Alright. I feel like I have to be making noise while I'm doing this. Hence all the noises. Alright, let me redo some of the things that got messed up. There's a minus sign there. Alright, that's relatively well reconstructed. So now we're going to take our second first order condition, which is the derivative of our payoff function with respect to j, dot dot, meaning I'm about to write it. And the first thing I do, of course, is always recognize all of the j's in the whole equation. And that was a j as well at the end here. Got a little bit erased. So once again, it looks like we're going to need to use the product rule here, but not in the first term. There's only one j in the first term, so we don't need to use the product rule. And then we just need to follow all of our j's back to their source. So here j influences f. Here j influences t, actually. So this qs just behaves like a constant in there. So even though there are more parentheses than usual, there's really only one relationship between t and j here. So this will actually be a simpler problem. So here we just have j times all this stuff, which behaves like a constant. So this is just going to be the constant, which is this and m. So m, and then p of k, all this junk that we're pulling down, f, I, r, s, a whole bunch of things. So that's just the constant multiplied j in the first term. That was super easy. Now the second term, it's product rule, so we need to define our two terms. And there's an s sitting here, so I'm just going to put that as part of the first. And we're just going to put a 1 there. So that's our first times the derivative of the second plus second times the derivative of the first. And then this is going to be our second function of j. So let's do a minus sign here and then big brackets so that we don't forget to distribute our minus sign. And we'll do first, meaning pick up the first and then put it down exactly like it appears, first, times derivative of the second. So this is going to be derivative of t with respect to j. Since j is our choice variable, we're just following that down its path. And we have to remind ourselves that t is a function of a whole bunch of junk, w, in addition to j. Plus, so first times derivative of the second plus second, so let's just pick it up and write it into our equation, equals 0, exactly like it is. T is a function of all this stuff, Q, S, W, J, times the derivative of the first. So this is going to be, well, S is just a constant sitting there, so we can just pull down the constant S. And then F of J is going to be derivative of F with respect to J. And that's it. And then we close our brackets, and it's a first order condition, so it always, always has to be equal to 0. And we're done with the problem.